Tonight, a silent but urgent global race is underway. Not for oil, but for rare earth elements like dysprosium and terbium. These elements, though rarely discussed in everyday conversation, are quietly shaping the future of technology and global power. These obscure metals are the secret ingredients powering everything from smartphones and electric vehicles to advanced fighter jets and renewable energy systems. Without them, the digital world as we know it would grind to a halt, and the next wave of innovation would be stalled before it even begins. For decades, the West has allowed China to gain a near-total monopoly, now controlling over 90% of the world's supply. This dominance didn't happen overnight. It was the result of strategic investments, government support, and a willingness to bear the environmental costs that others shunned. This isn't just an economic issue, it's a matter of national security and technological independence. Whoever controls these elements controls the future of defense, energy, and communication. Policymakers are scrambling to untangle this dependency as Beijing flexes its dominance, threatening export restrictions. The world is waking up to the reality that access to rare earths can be used as a powerful geopolitical weapon. The result, shockwaves through global markets and a scramble for alternative sources. Investors, governments, and industries are all on high alert, searching for ways to secure their own supplies and reduce vulnerability. From California's deserts to Australia's plains, a new gold rush is on. Only this time, the prize is strategic metals. Exploration teams are racing to discover new deposits, and old mines are being revived with cutting-edge technology. The West once led in rare earth production, but that leadership was lost as environmental concerns and cheaper Chinese production forced mines to close. Now, there's a renewed sense of urgency to reclaim that lost ground. Now the challenge is to reclaim it before the next generation of technology slips away. Scientists and engineers are working around the clock to develop new extraction methods, recycling techniques, and alternative materials. This story is about power, technology, and the raw materials that fuel them. It's about the invisible threads that connect our daily lives to the deepest minds and the highest levels of government. The clock is ticking, and the world is watching to see who will control the building blocks of the 21st century. Every day, the stakes grow higher as new technologies emerge and global tensions rise. The West is racing to build a secure, reliable supply chain. Failure is not an option. The future of entire industries and perhaps even national security depends on the outcome. The outcome will define the technological landscape for decades to come. The cities of tomorrow, the vehicles we drive, and the devices we use will all be shaped by who wins this race. The race for rare earths is on, and the stakes could not be higher. In this high-stakes contest, the winners will shape the future, while the losers risk being left behind in a rapidly changing world. Rare earths like dysprosium and terbium are at the heart of the global tech race. These heavy rare earths are essential for high-performance magnets found in electric vehicles, wind turbines, and advanced military systems. Their unique properties make them irreplaceable, allowing magnets to withstand extreme heat and stress. The problem? They're exceptionally hard to find and produce outside China, which has unique clay deposits rich in these elements. Most Western deposits are rich in lighter rare earths, leaving a critical supply gap. As demand for green tech and defense grows, so does the need for these metals. Nearly every high-tech manufacturer must turn to China for these vital ingredients. This dependence creates a choke point, making the entire supply chain vulnerable to disruption. The world's green and digital future hinges on securing these unsung heroes. The US is fighting back, with the Mountain Pass mine in California symbolizing a domestic revival. Once nearly shuttered, this site now stands as a beacon of hope for American resource independence, representing a renewed commitment to reclaiming a foothold in the global, rare earth market. Once a global leader, Mountain Pass now produces mostly light rare earths, leaving a gap for heavies like dysprosium and terbium. These heavy rare earths are essential for advanced technologies, from electric vehicles to military hardware, yet remain elusive in domestic supply. Even as mining ramps up, manufacturers still rely on China for these critical elements. The supply chain's dependence on overseas sources exposes vulnerabilities, especially as geopolitical tensions rise and global demand surges. Australia's Lynas Rare Earths faces a similar challenge, strong in light rare earths but short on heavies. Despite significant investments and technological advancements, the gap persists, highlighting a global issue, not just an American one. The West has flour, but not the leavening agent. Without heavies, the supply chain collapses, production lines can grind to a halt, and innovation is stifled when these key ingredients are missing. The scramble is on to find new sources in Brazil, Canada, and beyond, or to develop new extraction technologies. Researchers and companies are racing to unlock new deposits and invent more efficient ways to separate and refine these rare elements. Until the heavy rare earth gap is closed, the West's high-tech ambitions remain fragile. Every smartphone, wind turbine, and electric car depends on a steady supply of these materials, making the stakes higher than ever. The imbalance is a strategic vulnerability that must be addressed. National security, economic growth, and technological leadership all hinge on solving this supply puzzle. The race is not just about mining, but about securing the right mix of elements. It's a complex challenge that requires innovation, international cooperation, and long-term vision. Without dysprosium and terbium, the West's technological edge is at risk. The future of innovation, security, and prosperity depends on bridging the heavy rare earth gap before it's too late. Relying on China for rare earths is a profound strategic vulnerability. In any dispute, Beijing can threaten to cut off supplies, putting Western economies and defense at risk. This isn't hypothetical. China has used this leverage before, as in its 2010 dispute with Japan. Automakers, renewable energy, and defense industries all face existential risks if supplies are disrupted. The Pentagon now considers rare earths a top national security priority, funding domestic projects and forging alliances. Governments are offering incentives to build new mines and processing plants and are seeking stable partners worldwide. The West's scramble is a race against time to defuse this ticking clock. The lesson is clear in Dubai, Weiten San, Osterdijkenstaan, Sinokrijkenstaan, Weinstagenstein, Minnekensan, Otterbijkensteirestein. City materials can't be left in the hands of a rival. The world is waking up to the urgency of securing these critical resources. The clock is running, and the stakes are national security and technological leadership. At the heart of the global scramble for advanced technology are neodymium iron boron, or NdFeB, magnets. These are not just any magnets, they are the strongest permanent magnets ever developed, and their unique properties have made them absolutely essential in the modern world. These powerful magnets are the driving force behind electric vehicles, enabling the motors that make them efficient and reliable. They're also found in the spinning turbines that generate clean wind energy, and in the advanced military hardware that protects nations, everything from fighter jets to precision missile systems. What sets these magnets apart is their incredible power-to-weight ratio. This allows engineers to design motors and generators that are not only smaller and lighter, but also far more efficient than older technologies. The result is a new generation of compact, high-performance machines. However, there's a catch. NdFeB magnets tend to lose their strength when exposed to high temperatures, a major challenge in demanding applications. To overcome this, scientists add rare elements like dysprosium or terbium, which help the magnets maintain their power even under extreme heat. In electric vehicles, these critical elements allow motors to operate at higher temperatures for longer periods, directly boosting both performance and reliability. This means EVs can go farther, faster, and last longer on the road. For wind turbines, especially those operating offshore in harsh conditions, these heat-resistant magnets are vital. They enable the massive generators to run efficiently, delivering clean energy to millions while withstanding the elements. In the defense sector, the stakes are even higher. These magnets are at the core of precision-guided missiles, advanced radar systems, and stealth technology, where reliability and performance can be a matter of national security. The reliability of these components can literally mean the difference between mission success and failure, impacting both safety and strategic outcomes. Without a secure and stable supply of these heavy, rare earth elements, the future of both green technology and national defense is at serious risk. Shortages could halt production lines and compromise security. The intersection of energy, environmental sustainability, and global security makes these elements truly indispensable. They are the hidden link connecting our clean energy ambitions with our need for safety and technological progress. The global race for these resources is about much more than economics. It's about who will lead the future of technology, innovation, and security in the decades to come. That's why securing supplies of dysprosium and terbium isn't just a technical challenge, it's a strategic imperative for every nation invested in the future. China's dominance isn't just in mining, it's in processing, the most complex and polluting step. Separating and refining rare earths is a technical, hazardous process that China has mastered while the West shut down its plants. Even Western-mined ore often goes to China for final processing, creating a critical bottleneck. Beijing's control over processing lets it set prices and restrict supply at will. Export controls, quotas, and technology bans give China powerful leverage over global markets. Policy shifts in Beijing can spike prices and disrupt supply chains overnight. This uncertainty makes long-term planning difficult for Western companies and governments. The message is clear: control the processing, control the market. The West's urgent challenge is to build its own processing capacity. Without it, supply chain independence remains out of reach. The West's strategy to break China's grip is threefold: mine, process, and recycle. First, diversify mining by supporting new projects in allied countries. Second, build processing plants outside China, an expensive but essential step. Governments are funding facilities in the US and Australia to create a full mine-to-magnet supply chain. Third, innovate in recycling, recovering rare earths from old electronics and motors. Companies like Apple and startups are pioneering new recovery methods. Recycling reduces the need for new mining and lessens environmental impact. Success requires progress on all fronts, with unprecedented cooperation between governments and industry. There's no single solution, only a coordinated, long-term effort will work. The race is on to turn this strategy into reality before dependency becomes too risky. Progress is real. MP Materials now separates rare earths in California and is building a magnet plant in Texas. Australia's Lynas is expanding, with new processing in Western Australia and a US-funded heavy rare earth facility in Texas. Brazil's Serra Verde is tapping unique clay deposits, potentially adding new sources of heavies. Canadian projects are advancing, diversifying the supply base. On the recycling front, Apple's robots and European startups are recovering rare earths from old devices and wind turbines. These efforts are still small, but they're crucial building blocks for a resilient supply chain. Each new mine, plant, and recycling breakthrough brings the West closer to independence. The vision of a secure, circular, rare earth economy is taking shape. The foundation for a new supply chain is being laid, one project at a time. The path to rare earth independence is long, costly, and complex. New mines and plants take years and billions to develop, and the West will rely on China for some time. Economics are tough. China's low costs and state support make competition hard. Government backing is essential to attract private investment and stabilize prices. Environmental standards add cost and complexity, but are non-negotiable for public trust. The industry must prove it can produce responsibly, avoiding past mistakes. Faster permitting, stronger public-private partnerships, and real international cooperation are needed. Research must focus on reducing rare earth use and improving recycling. The stakes: technological leadership, economic prosperity, and national security. The race has begun, but the finish line is distant. Only bold, coordinated action will secure the future. The world's technological destiny depends on winning this race.